Hey everybody, we're back streaming live. We have power now here in Texas. We do not have water, but we do have power. So power is on, but water's not on. So we're making do with as is. And we're going to start with some chapter 5, part 2 for Stats 101. So let's get to it right over here. Let's do it. This right here is one of my favorite problems. I'm glad to start with this problem today. Hopefully some people will show up in the chat. We'll see who shows up. Feel free to say hey if you're in the chat. This is the best problem. This problem right here is probably best done with the David M. Lane applet, but I always like guessing this problem. You'd be like, why do you like guessing this problem? Well, it's fun. It's a fun problem. I know you think I'm crazy to say that, but I think it's pretty interesting to see how close you can get to these answers with taking guesses. It kind of shows, hey, what's up, John? So good to see you here. Thank you, John, for showing up. We're just doing some chapter 5 empirical rule. Ask questions when you got them. If you have a specific problem you're working on, feel free to ask, and we can work on that problem. But so good to see you, John. Thank you so much. I'm waking up. Might grab some lemonada. We don't have water, so just drinking lemonade basically. It's like, I think it's a French sparkling drink. We have like three cases of lemonada. So no water, just lemonade. So and milk. Yeah, we're doing all right. Just no water. Power's back though. So right here we want to plot the area greater than a z-score of 1.2. Now, when you draw out the normal curve, let's show the normal curve right here. every normal curve you draw should look the following way. There we go. That's a good normal curve. And so what I'm going to put in the center of this is the standard normal. So the standard normal has, can I back up? Can I undo that? Thank you very much. The standard normal has z-scores on it. So the standard, so yeah, we're doing pretty good. It's, it's pretty crazy, but we're lucky. We were in the rolling blackouts. So people probably wonder, like, Brian, how are you able to respond to your emails if, because I was responding to emails, probably like, wait, do you have power or do you not have power, Brian? For a while, we would have power for like 30 minutes and then it'd be out for like an hour. Generally, we'd be lucky if it stayed for like 40 minutes because the blinky clock, we've had power for 11 hours, 55 minutes right now. I can tell because, you're not going to reset your clock. Because if the power keeps going out, you're not going to reset your clocks. So there's a clock over there that every time the power would reset, I could watch it. And then I'd look over like, oh, 35 minutes of power. And then like a minute or two later, I'd be like, ah. So I got in the habit of knowing that around 30, 35 minutes of power. If you watch some of the streams that I did when I was losing power, one of them lasted like 20, 25 minutes because I booted up. Like once we got power, I immediately booted up the computer. I started streaming. And so, it's like you can tell about how long I had power because I did 2 streams or did 3 streams and they pretty much lasted as long as I had power because I was doing them right when I had power. And I decided, I got really afraid because I was like, what if the camera shorted out? Because like, I don't know. It's like, what if certain things short out? And I was like, if the camera goes, I use a very nice camera. And I was like, oh, Haslam's probably not going to. And I was like, I don't know. And I didn't know if YouTube would get mad if I kept streaming and like crashing my streams. I was like, what if it messes up the channel? I don't know. I got a little bit afraid and I was like, okay, I can keep replying to emails and stuff. And I sent out, like, I tried to get everything coordinated, but we're back now, I think. And then we'll get water back. We'll get water back. Everything will be good. Life will be normal again. Woohoo! That's what we like. So this is a z-score greater than 1.2. That's what we're working on right here. A z-score greater than 1.2. We can see there would be on the graph. We can see it'd be right here. So let's put where 1.2 would be at, and we can graph it. Now, I would suggest having a sheet of paper out and trying these examples. Hey, thank you so much. We're doing pretty well. Just no water, but other than that, pretty good. No water, but pretty good. What's the answer going to be right here? Does anyone see my answer? Who knows what my answer is? Oh, I can't really guess these because I can guess, but what? This is so crazy lately. What is the answer? My drawing's okay. I give myself a B+. Looks a little too much area. It's a pretty good drawing. So the answer for this one is for a z-score greater than 1.2, and we're going right here, greater than a z-score of 1.2, and this is the area. Now I know a special number. I know 1.2818. You don't know that number. Let me explain why I know that number. 1.2818, if I go above 1.2818, no, 1.2816. 1.2816, totally, 2816, totally unrelated to this problem. The area above that should be 10%. You don't know that number, but that's 10%. That's an 80% confidence roll. That's what you get for teaching the class for a very long time. So if we move it over here a little bit, that's going to be close to about 11.2%. So this is what we want. I say it's 11.2, and it's 11.5. So I'm pretty good at guessing these usually. I guessed 11.2%. It's 11.5%. I just like guessing these numbers. So this is 11 point, I would have said 11.2 had I guessed it. So my guess, it's not close enough. You got to be within a few tenths of a decimal. Please note I'm on the David M. Lane applet. I'm going to send this in the chat, the David M. Lane applet. That's not the David M. Lane applet. Actually, Mubot. Mubot's awake. Mubot. Put the David M. Lane applet chatlet in the chat daplet. Mubot. David M. Lane applet. He responds to the command !David, and he should. There we go. Thank you so much, Mubot. So that is the David M. Lane applet, and you're seeing it on the screen right now, and we can get the exact areas under the normal curve, but using the empirical numbers, you can get a pretty good guess. I would have guessed 11.2%, and I would have been kind of close. Also, and I should still have it on my phone, even though I'm always losing space, did I delete that? No way, I guess I did. Oh, no, I didn't. Of course I did not. Oh, I did, because that's downloaded from the cloud. It's a really good applet by Matt Bogner, a probability distribution applet. Apparently I have enough space now on my phone, and you can't see it. Maybe I'll show it just right. It's the normal curve. Wait, there you can see it. You can see the normal curve. It's on my phone. Probability distributions by Matt Wagner, University of Ohio, I think. Or wait, should say at the bottom, or it doesn't. Matthew Bogner, PhD, Department of Statistics, University of Iowa. So thank you, Matt Bogner. You can do it on your phone also. Really great way right there. A few people I know the years have downloaded. We want the z-score less than 0.75, and that's positive 0.75. Please note you need to know if the z-score is positive or negative. That means it's above or below the mean. So let's go right here. 0.75 is going to be right here and below. Now, these are the parts that I do for fun. You can just enter it straight in. If you're solving this, well, one, draw it out. When you draw it out, that means you're going to know what the answer is from your drawing. And then two, you should have an estimate. Well, it's obviously more than 50%, but this is where the estimate gets a little bit iffy. And I think I know some numbers here to help. This is where, if you were doing this, it's 0.75. I would go here to the David M. Lane applet, and I'd go below, and I'd go below 0.75. And that's going to be the answer. I'm not going to look at the answer right now. Hey, thank you, Michaela. So good to see you here. Doing well, doing all right, surviving. We don't have water, but we do have electricity now for 12 hours and 1 minute. Clock's blinking 12:01. So we just passed 12 hours of electricity. So hey, hopefully it stays on. A number I know for this is 0.672, I think. I think that's the number. And below 0.672 should be 75% of the area. Very close to it. So that means if we're at 0.75, we're going to be a little bit more than 75% of the area. And it's just coincidence that this is 75% below 0.75. And so I'm going to say this is 781. 773, 77% of the area. So I was within a percent. So you can see, you can get kind of close if you know some numbers on the curve. I'd say it's about, 77% or 78%. So 77.34, I'm going to copy the numbers here. Copy paste, your best friend. You don't need to write these down. Go here and really? Okay, copy paste is not your best friend. Copy paste will get an answer wrong. So now we go right here and we do the next problem. It says, this is going to be between a z-score of -2 and 1.25. So between a z-score of -2 and 1.25. Between a z-score of -2 and 1.25. We can get super close to this one. This is a tough one, though. -2 is here. 1.25 is here. Using the empirical rule, this is half of 95. So that'd be 47.5 because half of 95, because in between -2 and +2 is 95. So that's an empirical rule trick. And then 1.25 is very, very close to an 80% confidence interval. So that's going to be a little bit less than 40. So that's about 39%. That's a guesstimate from empirical rule numbers. So my guess for this answer, this is Brian's guess. You don't have to do Brian's guesses. 47.5 plus 39. If I had to guess the answer, 38.6. 86.5. 86.5. So -2. I said 86.5. Here's my guess, 86.5, and I was within 0.6. Your film was in Dallas. They have power mostly, but they have to, yeah. So we think we have to boil our water. We think we're under a boil water nose. We don't have water right now, so it's kind of a moot point because we don't have water. so it's like, hey, maybe we do have to boil our water. If we do, we'll boil it when we get it. But were they through the rolling blackouts? Did they experience that? They might have over the last few days had rolling blackouts where they were shutting off the power. I'm just waiting. I'm so used to it now. I'm used to just be talking online and then everything shuts down. But we might be through the rolling blackouts. We might be through it. We'll find out. This one right here looks odd. It's the outside portion, and this is a tricky one. This is tricky. It's going to be this answer right here. It's the outside. It says a z-score greater than, or a z-score an absolute value greater than 0.8. So if you plug in here -1, -1 would be greater than 0.8. If you plug in 1, 1 would be greater than 0.8. So this shaded region satisfies the absolute value of the z-score is greater than 0.8. So with this right here, this is the graphic. This is going to be less than 50%. This is a very tough one to estimate. It's going to be between 32 and 50%. I'm just gonna do a quick guess on this one. This is just a very quick guess. 43.24. Watch me get it on the dot. Like, watch that be the exact answer. So you go outside negative 0.8, and we'll draw our graphic. Well, we saw what the graphic looked like. Oh my gosh, 42.37. That's a really close guess. Okay, it's close enough. I'm very proud of that guess. Did I type in all? Oh, did I not select one? I didn't select this graphic. So we do the between right here, and this is the outside. I think I typed in everything correctly. Oh, no. 2 decimals. 2 decimals. Brian's still waking up. Let's double check. Okay. This one is greater than 1.2. Greater than 1.2. We'll put it right here. Greater than 1.2, and that's the area right there. This one is less than 0.7. That's area right there. This one is between -2 and 1.25. 87.16. 2 decimals. Has to be. Oh my gosh. I can't. No, I'm not even joking. I can't believe this. That's such a ridiculous. Like, I'm still waking up. They had like 12 different power turn on off. Yeah, exactly. Who notices what I got wrong? I don't think this counts. If you got this wrong, I would. This is Brian's brain. Please email me if this happens to you. I didn't get this wrong. It doesn't count. That doesn't count as wrong. I would email Brian Stevens and I would say, Brian, what would I say? What would I say? I'd say, look at my answer. I swear I know how to do these. I followed your video. I learned how to do it. What error did we make? We don't know the difference between commas and decimals, which we don't teach in this class. And now we check our... Did I not change my answer? Let me look at this. It's got to be this last one. 42.37. What is going on, Michaela? When I clicked... I'm going to rewatch this video. When I clicked back down, because I have the area here. For those thinking Brian doesn't know how to do this, because no one's saying that. Here's the area. Here's the graphic. It's the area outside of it. So, yeah, it's that graphic. So I don't know. But I had to have changed that when I clicked back down because I had the comma there. And then if I had selected this graphic, I would have gotten 2 wrong. So when I was clicking around, I must have clicked. So this is just, man, it's just one of those. It's just one of those mornings. Just one of those mornings. There's the rain we need to push away the snow and the ice. I don't know. It's still freezing temperature, so maybe we don't want that rain. Let's do an easy problem. Let's do a super easy one. I do love that previous problem, but not today. Not today. So this one right here, you'll notice that the distribution is heavily skewed. This is not the time we would use the normal curve. If we did a normal quantile plot, which I'm mentioning it now because it's something you should know, a normal quantile plot has 2 looks to it. A lot of people forget this part of the chapter. This is also called a normal probability plot. A normal probability plot, if it is normal, when a normal probability plot is normal, how will it look? A normal probability plot, when it is normal, look the following way. It'll follow a straight line. That's not a linear relationship. It's just that the normal probability plot follows the normal. And these are kind of the bands of what we would expect. And if it's not normal, it will be looking like this. So normal probability plots that are not normal look like the one on the left that are kind of not following a straight line. And these are the ones that are normal. Just so you can see, I can't reiterate these things enough. So let's hop over here to where I can make them really quickly. I just like using R because I can make normal probability plots in like half a second. So let's go up here to a new sheet. And let's just go here to data and R normal and 1,000 numbers. That makes 1,000 random normal numbers. You don't need to know this code. And then let's bring up where I can make my normal quantile plots. This just gives me abilities to make them. And here's what it should look like. This is what it should look like. Follows the normal line. And this is what the histogram looks like, as you would expect. But our histogram does not look like that. Our histogram looks something like... Our histogram looks something like this. And that means normal quantile plot will look something like this. Like I said, it doesn't always bend one way. This one is right skew, so it's kind of pushed to the right. You don't need to know that kind of stuff. That just does not follow the red line, where this one right here follows the red line and is normal. So once again, normal histogram means normal probability plot will be linear, follow a straight line. And then a skew data set. Do you have any tips for write up for assignment 3? I feel like I'm getting way too wordy. Feel free to send it to me and I'll take a look over it. And this is, Snea, this is something you guys covered too, because this is your last few questions. Does this make sense here? Because when you do the associate function, this is really good kind of mentioning for your assignment. When you do the associate function for the last part of it, you will have to do something like a really good bridge into talking about 320 for just 2 seconds. Oh, I know the names of them in Survey 10. Survey 10 doesn't have, you can do GPA and Greek. No, we need to do like handedness. Handedness. Wait, but we didn't put the data set now. Make sure to use, there we go. All right, here we go. So, yep. Oh, that's so awesome. Thank you, Snea. That's excellent. Yeah, you are super on track then. That's what I wanted. Thank you so much, because we should have class today if you're in today's class. These, no, there's non-normality down here. Look at the non-normality. And you can see the p-value for the medians is going to be very high or very low, which, look at right here with this red line, which I know the red line is low, but that means the p-value is going to be very high. This is the p-value. So I can tell the p-value is probably about 1.9 or something. It's going to be a very, very high p-value. So a p-value of 0.9, I guess, for the medians. Testing the medians, we get a p-value of, oh, look at that, 0.9. There it is. And that was my guess from the area shaded to the right of this red line. There's no statistically significant difference between the medians. And so we have side-by-side box plots up here. And people's handedness does not look to be associated with someone's GPA. And yeah. Oh, feel free to attend today's class. Send me a quick email and I'll send you a link to it. It's later in the evening. But if you want to attend today's class, you are more than welcome to. And maybe I'll send out that invite to the whole class. Maybe send me a reminder, like, hey, Brian, invite the whole class to today's class. So that way people can watch live and ask questions. Sorry that, and everyone understands. Everyone's been so nice about this. No one's like, why aren't you teaching? Be so mean. I'm like, I don't have power. I got the power. So according to the normal, what percent of receivers would you expect to gain fewer than 2 standard deviations below the mean? So 2 standard deviations below the mean. So let's go back to our normal curve. And this is according to the empirical rule. And I actually already have something here to help us out. My arrow just is a little bit off. So how did I get this amount here? Well, 95% is between here and here, so I cut that in half. But you can get it a few other ways. Like, we're trying to find that area right there, which has to equal... Quick question about Project 1. Do we need to include... Nope. Raina, great question. Yep, don't include those. Do not include the graphs in your executive summary. And if you're in my section, you can send me your report for me to look over. A lot of people have. I give advice. But Raina, great question right there. Do not include the graphs. Or the data, but you want to include like the numeric findings. One thing I also did, I'll talk about that here really quick. So here, I'll do this question. Raina, stay tuned. I'm going to give some good hints. Thank you everyone so much. I love like showing up and talking to everybody and helping out. Like I get so bummed. Why can't I do this? For these datas, what does this mean? The mean is 500. I'm rounding. The standard deviation is 300. 2 standard deviations down is 100. Something, so some procedures should gain less than these yards. You can find this exact number if you go here and take the mean, 47, subtract 1 standard deviation, subtract 2 standard deviations. I made a mistake because I didn't do the extra 3. 487 minus 336 minus 336, and there's the negative 185. There we go. That's 2 standard deviations below the mean. Explain the problem in using the normal data. It's skewed to the right. Not today, Matt Pearson. There's our 100. So something I did, Raina, that I thought, I think you're in our sections. Maybe. You can inform me if you are or are not in our sections. I did for Project 1, to make this easier for my graders, and I really think we should be doing this for everything. This is my preference, I started doing this, and I said, and people can tell me if they like it. People are like, no, Brian, that's a horrible idea. I'm like, okay, then I won't do it anymore. For the projects, I have now created rubrics, and this is what my graders will be going by. So if you receive any advice from your teacher, please use it. We are pretty standardized on what we do, but always do what your teacher asks. Anytime your teacher's like, I would change this, and then be like, if you get points off, be like, I changed. You said to change the thing. So because we're 4 different teachers, and sometimes we give a little bit different advice. But I went through and I pretty much allocated the points where I thought they should be allocated. And so if you'll notice, it literally goes by what I did in my videos. So you have the executive summary statement of the problem. So you need to make what you're saying for what's going on with what you'll be working on very clear. Clearly explains who the report is for and who was researched. That's how you get the full marks right there. Overview of the results. Results are detailed with numeric backing. And look at this. You could lose a point for not doing enough numeric backing. Or if you just kind of talk about stuff, but you don't give numeric backing. What do I mean by numeric backing? Someone's probably asking that. I mean, you cite the numbers. Instead of saying, we looked at the mean and the median, or we looked at the median because the data is skewed, you would say, the median of 3.8 was found. Now, you don't go through and list every single finding they got. You want to summarize. Look at my project videos to see how we're going to take a paragraph like this and boil it down to something like this. You just want to take these large portions of text and boil them down to something small to get the big ideas. You're not going to take every idea that they wrote. You're going to take the big ideas. So, big orange, big ideas. That's what we say. And executive summary action items. So what's an action item? Action items are like things we're going to do from this. What will the Student Success Center do from this research? What takeaways are they? So you need to make sure these are in the executive summary, because the executive summary should have everything. So if you put them in the future research, you will lose credit. You will lose credit if you put them in the future research. Suggestions need to be in the executive summary for credit. You can't put them in the future research down here because the future research is for future research. And that's what it's going to be graded on. The future research is graded on ideas are given for future research. Now, if you give ideas for future research and you're like, we should give out chocolate on Ped Walkway, I'd be like, I might give you 0 marks. I might be like, what? But if your ideas are kind of not connected with the goals of the Student Success Center, you could lose points. Like it's like maybe an idea for students at UT, but it's not connected to the goals of the Student Success Center, which is to help students, be successful in their college careers. So you could always say, hey, Brian, I think I shouldn't get points off here. Like you can always debate points. Like you'd be like, hey, Brian, I lost 2 points. I think I should lose 1. I'm always open to that. Last but not least, we have neatness and grammar. Do not include the instructions. Do not include the instructions. That should be, oh, darn, I have to change that on each one. That should be 1 point. Well, darn. Let me go edit that on this one. And then I got to edit the other ones. Why does it say 2 points there? Okay, good. All the other ones are accurate. Do not include the instructions. 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 Why is it? I guess it's the in report. Oh my gosh. This is what happens when I... Oh, that says or. That's what happens when I work on something late at night. No electricity, no power, no water. On off electricity. Sounds like you don't have electricity. So that's hopefully more clarification on what to do. Here's everything you'll be graded on. I've already graded a few people using this. I think it makes grading nice and easy. Also, you can see where you lost points, and you can debate where you lost points. I'm always up for debate, so let me know if you think you shouldn't have lost points. There we go. Yeah, you're welcome. No, anytime, Raina. Glad to help out. We're doing fine. Just I'm just trying to wake up. I didn't get coffee this morning. I knew I should have bought more of my Starbucks drink coffees. I was like, we got a Keurig. We got a Keurig. Not like we're on a boil water notice. The mean time was this, and the standard deviation was this. If the normal model is appropriate, what percent of times will be less than this? The best way to look at this problem is the mean is 103. The standard deviation is 4. What percent of times will be less than 107? 107 is how many standard deviations above 103. So just think of 103, think of 4, think of 107. That makes this a z-score of what? Like we have 103, we have 4. Don't look at the decimals. This one always goes to a nice whole number. So we have 103, we have 4. Hi, Brian. As you really, oh, thank you. Yeah. Yeah, we're back a little bit here. And we're gonna hold class today. If you're whichever class you're in, I'll send out a link to both like sections and be like, hey, just so you can get some live instruction, and it'll kind of put us on track. I can't really do activity for both classes this week. I guess I'll give one class the credit. I hope it's the other class because I gave one. Anyways, we'll get it figured out. This one right here has a z-score of 1. A z-score of 1. Thank you, everyone, for all the positivity. I appreciate it. I got so many nice emails from people saying, hey, Brian, just making sure you're doing all right. Observation minus mean over standard deviate. Well, standard deviation is 4.15. So what are we going to get right here? We get a z-score of 1. We take this z-score of 1 and we go and we plot it on the normal curve. So a z-score of 1, I think it said below. I have definitely gotten this problem wrong because I've gone the wrong way. Make sure you check your problem. Your problem could be a below, it could be above. Just make sure. There's only 2 possible answers right now. When we do this problem now, let's put, oh, my curve's not symmetric. Should be symmetric, This is going to be 68. That's the first number on the empirical rule. And that makes this arrow 16. And if this arrow is 16, this arrow is 84. Say, how did I get 16? Well, total outside of this is 32. If 68 is inside, then total outside is 32. And my curve should look symmetric. It doesn't because my drawing is failing me today. But I cut 32 in half. And you can see it on the David M. Lane applet. You can see a more exact version of it. Where'd our David M. Lane go? Did we delete David M. Lane? Tisk. Mubot will always tell us about Mr. David M. Lane's applet. This guy just wanted everyone to say his name 10,000 times. He's like, I shall be ever, forever known. If you go right here to the middle 68%, you can get, there it is, between about -1 and 1. It's 68.26, I think, to be more exact. There you go right there. So that's the more exact, but we just say 68, 95, 99.73. And 95 is 95.449. There we go. It's 95.449, but don't know those numbers. 68, 95, 99.7. So here's the answers. It could be 16 or 84 because 68 inside, 32 outside, and then above 1 is 16%. Practice breaking down the curve with the empirical numbers. We want less than, so that's going to be 84. Power just blinked. Don't go out, power. We should be fine. What is the actual percent of times? This is where people usually make a mistake because it's a little confusing. What is it asking? It's looking at these times up here, these 53 times, and it wants the actual percent less than 107.21. 107.21 would be right here. So there's 1, 2, 3, 4, 5 times above. And if there's 5 times above, there would be 48 times below. We're not going to count that. We're going to subtract. So 48 out of 53, and that's 90.56, 90.57. Round to 1 decimal, 90.6. Now, I've done this problem a lot, and the way this problem usually works is they want you to say that they're different. So right here, do the 2 percentages agree? No, because the normal model is not appropriate. I don't think they've ever matched up. And then they want us to look at a histogram of this. So we could do this inside of, there's a few ways to look at this. We could go over here and plot it. Can we? No, we can't. Here we go. We could copy to clipboard, copy. I have a really favorite way of doing this inside of R. There's a trick that I came up with. Ooh, is this going to work? You have to go right here, I think. You have to make sure you have enough spaces. Will this work? And then you have to go here, and you have to hold Alt-Shift. No, wait, Alt-Shift. Yes, did it. There we go. And then you go right to here, and you let go. It does it. And so I think we've done it. There we go. So now if I go to hist of data, there's the histogram. It's a right skew histogram that answers the question. but we can also do this inside of jump. So the answer is going to be, ooh, which one is it? The bin widths are interesting. Let's go inside a jump and do inside a jump right here. I just wanted to do my favorite trick inside of R right there. Here's the data, graph, nope. Analyze distribution. And let's take a look at it. Is it really that one over there on the far right? I guess it might be. Huh. It is really that skewed. It's not left skew. Is it centered around between... No, because that's more outliers. It's got those 3 outliers. And there's those 2 right there. And there's those 2 right there. I think this is the one. I don't want to get another one wrong. Let me change the bin width with the hand tool. That looks about just like that. How many observations are over there? It can't be this. There's gaps. There's gaps in the data. It has to be this one. There's gaps. And that's right below 122. No way there'd be enough data, no matter how they do their bins. Can't be these. Can't be that, because that's left skew. That's right skew. The only 2 it could be is this one. That's unimodal symmetric. That's, yeah, it's got to be. I'm second guessing myself way too much right here. So it has to be that. What can be seen from the histogram? It's got right skew and outliers. So the data is not normal and skewed to the right. Yeah, I got one wrong today because I put a comma in and then I clicked the wrong button. And now I'm just second guessing myself every second of the day. I can't do that. Gotta be like, I know how to do this. I know what right skew, left skew is. I got this. D is right. I selected that one and got it right. Thank you so much, Lucy, right there. Yeah, I was like, I did it 2 ways. I did it inside of R right here. R. And we can look at the QQ plot for it now. We could look at the Shapiro-Wilk normality, which we do have in Stats 1 also, which says, nope, not normal. Reject normality right there. That's in 201. Both of these things are in 201 right here. So this histogram right here is right skewed. We see that there's some non-normality in the normal quantile plot, and the p-value is below 0.05. And so that is evidence of non-normality. If we had data that was normal, the Shapiro-Wilk would come back with a little bit higher of a p-value. There's a bit higher of a p-value. The histogram would look more normal, and the QQ plot would follow the straight line. So this is what it looks like when it's normal. Follows a straight line, unimodal symmetric distribution, high p-value when testing normality. This is what it looks like when not normal. You're going to see here a lower p-value. This is scientific notation for a very, very small p-value. And then you're going to see one that does not follow the straight line, so accordingly. So kind of a good review of those topics right there. And you'll see it via jump output. It'll look the same, but it'll be in jump. So right here, we want the highest 10%, the lowest 20%, and the middle 40% on a curve that is normally distributed. That's what the big N stands for right here. The first number is the mean, the center of the distribution. The second number is the standard deviation, 82, just up and down each way. David M. Lane makes this so easy. David M. Lane's in the chat right now, so be looking at the chat. And 111, there we go. 1151 and 82. So our life is super easy with this because we can just go in here and enter in the top 10%. Now the top 10% is also the 90th percentile. We should know that this is also showing the answer as the 90th percentile. Take your answer, copy paste, bring over your answer right here and change it to 1 decimal. The lowest 20% of steers is going to be on the other side of the curve. So the lowest 20% of steers is right there, but also we could find the answer a multitude of ways. This is good to know that the following would be the answer. I'm just trying to think. Nope, that wouldn't be the answer. This would be the answer. 40% is on the outside right now, means 60% is on the inside. This is the 20th percentile. This is the 60th percentile. How do I know this? Because if 40% isn't no, this is the 80th. Oh my gosh, my brain is breaking today. Because 20% would be here and 20% would be here. If you have access to the applet, I would not solve it this way. If it says the lowest 20%, I'm going to go here and enter in 20%. Just make sure to know what this graphic is showing you by looking at the area and know that this is the point it's talking about right here. So let's go grab the number. And that's all going to round up. That's 1082. It's all going to round up, right? 1082. That's the one I'm going to get wrong. and 82. That's the one I'm going to get wrong. The middle 40%, so middle 40%, not outside 40%. Middle 40% is going to be if we go here and go middle 40. But there's another way we could get this. Look at the number 1107 or 1108, just about. We could have done this, and that's the same numbers, because if 60% is on the outside, 40% is on the inside. So make sure to note this is showing the outside, and 40%, this is the lower 30%. This is the, oh my gosh, yeah, that is correct. This is the lower 30%. This is the upper 30%. This is the 30th percentile. This is the 70th percentile. Just understanding what the curve is showing you by knowing that 60% is currently shaded is helpful. I really think I can't emphasize this enough, because I see a lot of people lose points when we show pictures on the test, because we might be showing you a picture of this and we might ask you to work with it. So just to emphasize what I would do and what I see in my head, whenever I see something like this, I immediately take the percentages it's showing, and I go right here, and I say, okay, there is 60% on the outside. Like, I know that these areas right here are total 60%. That means I can cut them in half, and that means there's 40% on the inside. That means this is the 30th percentile, and this is the 70th percentile. My horrible handwriting. So these are the percentiles right here, and that's about the information we can get. So it's very important to use the information you have to be able to understand what can you glean from this graphic. We can get the 30th percentile, the 70th percentile, the lower 30%, the upper 30%, the middle 40%. All of this information can be obtained right here. I've got a little over an hour to intro to statistics. We're good. We're going to go strong today. We got this. Okay. So now we need those numbers, whatever they were. So we have 1108. And we have second number 1194. Is that right? Good. We've done it. Next problem. This is the same sort of problem right here. It's just doing different percentages. So we just need to change, and here's what I'm going to do. I'm going to take this window and put it right over here. I'm going to take this window. I'm going to take this window and put it, should just use the auto connect thing. Put it right over here. This makes our lives a little bit easier so we can kind of see what's going on as we work the problem. So work smarter, not harder. That's what they say. So when we work this problem right here, we need to put in our numbers. Our numbers are going to be 1130 and 88. The curve shifts to a mean of 1130 and a standard deviation of 88, which means we're going up and down 88. We want the 51st percentile now. As percentiles go, the best way to do them is to go below that amount, because you can see here's the 10th percentile, the 20th, the 90th. Percentiles are below a certain amount. So 51st is literally going to be like 1132. Why do I know that? Because it's going to be right above the, and look, we were round to the nearest whole number. We got it right. We didn't even need the applet because it's right above the mean. So looking at the mean, I was like, well, it's just going to be barely above the mean. So pretty easy answer to get. At least we could guess that. So if we could do multiple choice questions on this. What is the 51st percentile? You would know it had to be between here and here. So we would usually put numbers outside of this range. Like if we do multiple choice, we'll give you numbers between 1130 and between 1218, like one number, and then the other numbers will be outside that range. Like we could put something right above here or right below here. So there's answers that have to be wrong now. So the 92nd percentile is going to be, we put in 92, and can I not, yay, I cannot show the answer. There we go. It's right here, and the 92nd percentile is above the, my brain's breaking, the 84th percentile and below the 97.5th percentile. And so you can look, I mean, it's about 1240, 1253. I was way off on that one. Round to the nearest whole number, 1254. The IQR, and now we need to know what the IQR is. The IQR is the interquartiles range. The interquartiles, every time you think of the IQR, you should immediately think of your four quarters. Go to your 4 quarters and draw in a color that is visible. And the IQR represents the middle 50%. It's the interquarters. So it's the middle 50%. It goes from the 25th percentile through the 75th percentile, the IQR. And so now we know what it means. And what's that mean? We need to graph the middle 50%. So let's go here to 50%. And let's do between. And there's the middle 50%. Same if you do between or outside. And now we need to round to the, we need to find the IQR. So the IQR is the range of those numbers. So we do big number minus small number. There's the big number. There's the small number. Round to the nearest whole number, 119. I'm going to get hit by a typo. I put a comma a little while ago and I lost points. Don't want to do that. Don't want to do that. We got that question down. Yay! Companies who design furniture for elementary school classrooms produce a variety of sizes for kids of different ages. Suppose the heights of kindergartners can be determined to be normally distributed with a mean of 3.92 and a standard deviation of 1.9. So we've got the mean and standard deviation. What are we going to do? We're going to go right back to David M. Lane. Let's make this a little bit smaller. There we go. And we're going to put in the mean and the standard deviation to both sides of this to make our lives easy. So 39.2 and 1.9. 39.2, 1.9. And anytime you work these problems, realize you're talking about heights of children or something like that. So if you get something like 50, the answer is a bit ridiculous. So what fraction of kindergarten, what fraction of kindergartner kids should the company expect to be less than 39 inches tall? Now, this one allows us to put in numbers and we get an area. So it says area from a value. This one allows us to put in the area and we get numbers back. So area, you get numbers. Numbers, you get area. So it says we know 39, so we're going to put in a number and it wants are going to be less than. So let's go here to below, 39 inches tall, which is going to be right about there. So 48%, 46%. Oh, darn. So we just put in that number right here, 45.8%. In what height should the company expect the middle 90%? So now we're given a percent. So we go back over to here, put in percent. Middle 90% is 1.645 is the z-score. So actually, is that showing the answer? There's the z-score of 1.645. And here's the answer right there. So we know the answer is 36.07, 1 decimal, and 42.3. There we go. At least how tall are the biggest 15%? So now we want the top 15%, which we could just go and put in. Well, this is going to do the top 15%. The top 15% is the 85th percentile, just showing 2 ways of solving it. There's the 85th percentile, and it's right above the 84th percentile. So we probably could have guessed that one, 41.2. It would have been pretty close. So this is, kind of one we could ask, sort of like on the test. Lots of ways to kind of have you guesstimate it. Why do I know that this is the 84th percentile? I think our curve currently shows that. This one right here. So if 84% is below here, we did this just a moment ago. This is the 84th percentile because there's 84% below it. That means if we wanted to ask you about the 85th percentile, you would know it'd be somewhere right there. So we can ask these sorts of questions on the test and have maybe multiple choice and be like, where do you think it would be? Would it be at, 40, blah, 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 43? It's going to be right above 41.1. So a lot of people want to know, like, how would you do this as a test question? And there's a few ways. There's some ways to make it so, like, you have to kind of know the empirical rule. Good question right there. I like that one. And here we are. Like, are there some you don't like? Yeah, there's a few I don't like. Here's the mean and standard deviation. Well, you know what we're going to do? We're going to write back to our friend, Mr. David M. Lane, and put in the mean and the standard deviation. There's the mean. There's the standard deviation. And we actually need the first one. Oh, no, because we're getting values. We're going to take these values and get the area, because the area is the question. So area from a value. And there we go. So percent of steers that are above 1250. So above 1250 is going to be right about there. It's going to be a little more than 2%. And, oh, I was wrong. It's a little less than 2%. I should have said about 2%. That would have been a good answer. Around to 1 decimal. Sure. Percent of steers below 1050. 1050 is right here. Ooh, that's a tough one. 19%? 19%, I say. So below 1050, I say 19%, 20.8%, or 20.9. That's right, 20.9. Percent of steers between 950 and, so we got to go between 950 and that. Ooh. So that's 0.15, 2.35, 13.5, 12% or so. 5%. Wow, my brain is just not. Wow, that's why we have the applets. Oh, you can't see the answers behind me. Sorry. Here were the answers. I guess because I had a little bit higher last time. So now you'd be able to see them with me on the screen. There we go. Now you can see kind of the applet and me on the screen. And there we go. 5.04. So that's 5%. I think we've done it. There we go. Let's see what the next question is. Very similar questions right here. If you notice, a lot of it's using the applet, understanding how to use it. So if you understand how to use the applet, life gets pretty easy on these questions. I know it can be a little bit tricky, but thank you so much, Leslie. I appreciate that. Yeah, doing pretty good. It's definitely just it's been draining, not having water or electricity. It's like I've been camping for maybe 3 or 4 days. Imagine like I'm gonna go camping all weekend, have no water, no electricity, and it's gonna be really cold out. He's just like, you're like, yeah, I'm a little drained, but no, I'm doing good. I'm doing good. Like we're lucky. There's a lot of people who had it way worse than us, so we had supplies enough to be able to make it through this, and so that's it's kind of what you want. You want to be able to make it through with what you have and be all right. So we've done it. So now we are going to get the percent, and we want above 80. So above 80 is going to be right about there. So above 80. And that's above 80. So 89.44. So many decimals. I wish it was just voice activated. I could say it, and it would just put the answer in. Approximately a billion percent of IQ is predictable below 85. So below 85, right there. See, we're going to put in this guess. There we go. Let's put in the guess. That's our guess. We were so close. That was pretty close. That was a good guess. Approximately blank percent of IQs are between 116 and 136. So 116 is right here, and 16% is above here. 136 goes to about here, so we're cutting off a little. It's going to be about 14.8%. 14.8%. This, whoa. I thought I almost did the answer. This is very similar to our problem right here because 116 has a z-score of 1. So if I go above 116, it's going to be 16%-ish. That's the more exact answer. And then above 136 is here, which is the hard one because 2.5 is above here. So that means about 1.5 is above there. So 136, 1.2%. So we don't want to, we could subtract those areas, but we can just go between, like, since we have the applet. Oh, so close. We're really good. We got our guessing game back. We're doing better at guessing. So it's kind of good to just kind of understand what's going on, to be able to look at the curve and have decent estimates of it. Oh my gosh, it's like the same question. I'm in Groundhog's Day. I thought that was early February, not right now. I didn't think today was Groundhog's Day, but apparently it is. So, there we go. Okay. So the curve has a mean of 21.6 and a standard deviation 21.6, standard deviation of 3.5.3. And we do need to know these are normally distributed. There we go. Okay. Above 32. So 32's over here. Let me vanish. 32 is right here. So this is one of those ones we can get a really good estimate on. So if this was class, I would pause and have everyone answer it, but it's with slower office hours, so I don't want to pause too long. But since 32.2, above 32.2 is going to be 2.5, this is going to be very close to 3. It's going to be like 2.8. So we can, how close would I have gotten it? Would I have gotten it right? So above 32, Ah, it's right at 2.5. That's because he has z-scores almost. So it probably would accept that. And because truthfully above 2 is 2 point... Because here I can find you the answer. It's 95.449. So 1 minus that. That's what's above 2 technically. And so there it is. It's rounded. So above 2 is 95.449 because a z-score of 1.96. I'm talking so much technical stuff right now. Is the actual 95% confidence interval. It's just we use rounded versions just to show very, very briefly. When we do the empirical rule, we use rounded versions of it for 68. That's basically 1. 95 is basically 2, but there's classic 1.96 for everyone know, like all statisticians know that number. And then 99.7. But it's actually, more decimals would be 68.26 is 1 standard deviation. 95.449, which it won't let me put in, is 2 standard deviations. And then 99.73 is 3 standard deviations. So those are the more exact 68, 95, 99.7. More decimal places would be 68.26, 95.449, and 99.73. You don't need to know those. That's why when we do 95, we're not getting exactly, see right there, it's not exactly where 2 is. It's just easier to memorize. So don't memorize those numbers. Don't worry about it. You should know 68, 95, 99.7. If you teach the class, you can memorize the more numbers like I do. About blank percent of students will have under 16. Did we lose? Is the applet not reacting? Oh, the applet stopped showing the numbers properly. So 21.6, 5.3, and under 16 is right here. Very close number again. So this is going to be a little bit less than 16. It's going to be about 14% and 14.5. Once again, the empirical rule is how we can estimate these things really quickly. Oops. We have the empirical rule so we can kind of make estimates in our head. I was able to know it's a little bit less than 16 because 16 is below a z-score of -1 using the empirical rule. Blank percent students are between 16 and 32. Oh, look at, oh, come on. This is so perfect. Oh, no, it's not an easy one because this is -1 and this is 32. We did one like this way earlier and it was like 84%. So I'm just going off of memory and remembering it's about 84%. Let's see if memory serves. 83%. Hey, Kayla, so good to see you. So from remembering earlier what that was, we got a very good guesstimate. And I think we've entered them all in properly. We did. So we are good to go. Let's hop back to the screen. Next problem, is it very similar? We're using, okay. So I think we're using the empirical rule for this one. Let's do some empirical rule stuff. What percent of cars would be between the middle 68%? And we need to select the right graphic. 68, 95, 99.7. They all do that. Excellent. And the mean is in the center of all of them, 27.2. And the standard deviation of 6.8. This one has too small of a standard deviation. That's too small. And this one's too big. This one goes up by more than 6.8. So that means this is the one right here. This is the correct graphic. So the middle 68%, we just need to take the numbers right here of 20.4 and 34. So that's the middle 68%. About what percent of autos should get more than 34 miles per gallon? So 34 miles per gallon. I have to sneeze. Every time you think you have to sneeze, you don't sneeze. It's just this way it goes. Get more than 34. My brain broke. There's 34 right here. 34, 68 inside. If 68 inside, 32 outside, 16 in either hand. What am I talking about here? We are doing a graphic like this. We are at -1 and +1, and we have 68% inside, because this is where 34 is at. And if we have 68% inside, that leaves 32 outside total. That leaves 16 in either side, and that's how we get the answer. So we have 16% is what is expected to be above here. So excellent stuff right there. It should be 16% is what is expected above a z-score of 1. And what percent of volleys should get between 34 and 40.8? 34 and 40.8 is between a z-score of 1 and 2. So this is where it gets pretty interesting, and we already have part of the graphic up. So now we need to go further and go to -2 and +2. So -2, +2. And that's because where the z-score was like 40.8 was right here. And so with those z-scores, we now want to talk about this area. So between -2 and +2 is 95%, 68, 95, 99.7. That leaves 2.5 on this side because that's half of the remaining 5% on the outside. So just to be clear, this right here is 5% total. What I've shaded is 5% because we're doing the outside region of the 95. 95 inside, 5% outside, cut it in half for each side. So take a look. If we have this area we're interested in, we want to find, trying to make it clear, 16% is the shaded yellow area. 2.5% is the shaded green area. So using the empirical rule, what would we do? We want to subtract off this region. We want to subtract off this green region right here, which I can't click on for the life of me. But we want to subtract off this green region, and we would cut that off. And what would we get? We are only interested in this area. We need to do like a different color for it, so it doesn't color coding matches. We want just this region right here. So the yellow region is from here over. The green region is from here over. So if we subtract those areas, we get this region. So we just subtract off, and so hopefully that makes sense with the color coding. You're just going to try to get this area right here. So it'll be 13.5. It's going to be 16 minus 2.5, just to show it mathematically here. 16 minus 2.5, and it's 13.5. There we go. Describe the worst 2.5% of cars. Now, we've kind of done this. We figured out the answer to this with the previous question, because if this is the best 2.5% of cars, the worst 2.5% of cars is over on this side on a z-score of -2. So all we need to do is go look at the z-score of -2. Here's the right curve. Go down 2 standard deviations, 13.6. And we see 13.6 in the answer, and that is it. There we go. Just finding the answers, knowing the numbers on the curve. We got more than enough time, right? We're doing good. We're doing good. What time is class? 33 minutes, I think. 33 minutes. So 68, 95, 99.7, 68, 95, 99.7. This one's wrong. These two are right. 100 is the center. That's the right curve. So the middle 99.7 is plus or minus 3 z-scores, as we can see. So that's going to be between 52 and 148. There we go with those. And about what percent of IQs should have scores above 132? 132 is a z-score of 2. So we can go back to here, and we've got our answer from previous questions. If you write these down, it'll really help. If you practice writing these out. Good to see you here, Clarissa. Good to see you here. And so it's going to be 2.5 according to the empirical rule. Between 84 and 100. Ooh, I like this one. I like this one a lot because we don't always do this one. It's not too hard to figure out. Between 84 and 100, let's grab our graphic. Between 84 and 100 is this area right here. Yay, thank you, Sydney. We are surviving. We have made it. We've got power back on. Maybe by the weekend we will have full water. I mean, that would be awesome. We have no water right now. Well, okay, we have some pots full of water. We have a sink full of water. We have pots full of water. We don't have running water. So that's 68% right there. 68% between those values. So what would that make these areas? I'm just going to throw the pen. That'd make this 34. That'd make this 34 because we're just going to cut that in half right there. So we cut that in half. And that makes both of these 34. 34% of the area according to the empirical rule. So we have done it. That's a good one right there. 34. And what percent of should have scores above 116? Above 116 is right here. So this is a very similar question. Because if you do just the remaining on this, well, from here over has to be 50% because it's half the curve. And so from here down has to be 50% because it's half the curve. And that makes this 16%. So that has the answer. A lot of problems you can use to figure out the next one. So just good practice right there. 16%. There we go. We were just doing amazing today. Very, very similar problem right here. So I might go through it a little bit quickly. I think we speed ran this one in the last one. So what size would you expect the mill 95%? Mill 95%. 68, 95, 9. Is this the same question? Looks very similar. There's the right mean, the right standard deviation. Mean 95%, 1.9 to 19.5. What percent would you expect to have below 1.9? That's a z-score of -2. So below is going to be 2.5. I always make sure below, correct. Between 15.1 and 19.5, 15.1 and 19.5, that's between 1 and 2. So that's 34, 13.5, 13.5. Memorize the numbers. And I should show something here again in a second. 23.9. And that's, wow. They're doing that one? Wow. I have the wow queued up. Type in do not round. Type it. Yeah, that's what they want. Wow. They went for the smallest possible area over here on the far side. I'm going to pull up the graphic here real quick. We have a graphic that we can use. Let me pull it up right here. So I'm going to pull up this graphic. 2 seconds right here. Very, very helpful graphic to use. So I've posted this. Please take a screenshot if you don't have it. It's posted under chapter 5. And where's the flip thing? Okay, there we go. So let's show the graphic. This graphic right here is super, 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 super helpful to use. And we'll full screen it. It will vanish. So if you don't have this graphic, please screenshot it now. It has all the areas on the curve. It's how I'm able to find everything out so quickly. Like that 0.15, I was instantaneously able to know because I know 99.7 in the middle of it between -3 and +3. That leaves 0.3 on the outside or half of that 0.15 on either side. I don't say this jokingly. I know all these numbers in my head. You can just be like, Brian, what's below a z-score of -1? And I'd say 16%. What's above a z-score of 1? 16%, because they're symmetric and there's the values right here. So this curve right here takes a little practice to use. And also you should be able to kind of find most of these numbers, but everything's given to you right here with the percentages on the left and the percent above on the right. These would be the percentiles right here as you go left to right. And we don't have one thing that's not marked is the 99.85 percentile, which would be right here, because above here is 99.85. So kind of a bummer that one thing didn't get marked. I should remove that thing on the normal curve where it says the normal curve. Put it down below here. Yeah, maybe I'll go in and edit it again. So thank you to the student who made this. We are so ever thankful. I should tell them to this day, we still use their curve that they drew. So sometimes students help in such big ways. Like not sometimes, it happens every so often. So right here, this one's tricky because it's 2 standard deviations. So don't be tricked. 750 plus or minus 2 standard deviations because you're going to 95. So if you look right here, this is going to be the right answer. A lot of people choose A because they think it's 1 standard deviation. This is going up 1, 2 standard deviations, going down 1, 2 standard deviations. Would it be safe for the roots requiring a shear strength of 700? 700's right here. So since this is at a z-score of -1, I'm thinking something like 16%. That's correct, because 16% are going to have a shear strength less than this. We are going to have class day. Yep. As long as everything, like 99% certain we're having class. I feel a little tired and this because yeah, sorry if you've already covered this, but is there a specific Z table we should be using for those that aren't normal? If they're not normal, we just can't use the normal techniques. Really good question right there. If it's not normal, we will not use the normal techniques. Is that what you mean, Michaela? Good question right there. And this right here, it asked 850. I'll graph this one while we're talking about this. So I'm gonna show the graphic of how I got that answer. I try to remember. I want people to watch these videos and know how to solve these and not just get answers. So when it asks below 850, my brain just starts. I see things. I see answers. I see if 95 is in the middle. If 95 is in the middle, then 2.5 is on either side. Because 95 inside, 2.5 on either side. Which problem are you working on, Michaela? Which problem? Which problem are you working on? Because we have the David M. Lane applet. On the test, you will very likely see pictures from the David M. Lane applet. You can use tables. You can use like Z tables, but I would not suggest it. Z tables are basically David M. Lane applet, but like you have to like look up the numbers. So the David M. Lane applet allows you to question 3. Let me take a look at that here in a second. What does the question say to start? It's probably similar to these. So I shaded and showed it. So this would be, if you go across here, this is 97.5. Here, I'll show you to solve it with the, I think I know what you're talking about. Are you talking about this one right here, right? This problem right here? I'll show you something really cool with this one. This is my favorite problem. This problem right here, it's not going to like, which one did we get to? We got to question 14. So I can reload this. That one's not normal data, cutoffs. We've basically done all of these. So so if you get a z-score below 1.05 on the David M. Lane applet, he'll bring up the David M. Lane applet. When you do a z-score below 1.05, let's put here the standard normal curve into here. And then you can go below 1.05. Now, what I should know is I know 84% is here. So this is going to be about 85.2% or so. And I was close. I was within a tenth because I know this is the 84th percentile from the empirical rule. And so Z-tables will get you these answers. But what's really great about the David M. Lane applet is you can put in more decimals and it'll find it for you instantaneously, and it'll also show you the graphic of it. And you don't have to worry about, like, are we doing the less than area or the greater than? Because Z-tables have a certain way they work. But if you want the area below a Z-score of a certain value, the David M. Lane applet will get you the answer like this. And then we do show pictures like this on the test, which may show you this information. So knowing how to read it. Does that make sense, Michaela? So using the applet right here, which we're more like, the reason people would say like don't use applets is because they're like, you won't always have applets, but you'll have tables. But I always like to point out to people, I'm like, well, I'll always have my phone on me, and my phone has the applet. Like I have an applet on my phone. You can't see, I'm holding it at an angle where you can see the normal curve on the phone. So I can actually solve these answers on my phone because I'm that big of a nerd. But I also have the empirical rule in my head to make estimates. So I use the empirical rule to make estimates, but you can solve these problems with these right here. Does that make sense, Michaela? Like, does it make sense how to use this applet right here? You can graph the area. Like if it says above a z-score. Yeah. No, I'll say this though. Definitely, you are totally 100% allowed to use the table. And my only fear, this is my only fear while I say this, is like, and oh man, I wish I could convince them to not use tables anymore. Because if you really want to get exact, like the super advanced way of doing this is to go over here and like you can get, my brain's breaking, p-norm, that's what I want. So if we're trying to, your question was 1.05, right? So here's the answer right here on the below 1.05. And then if you're doing it over here, this should give the same answer. So if you notice the decimal place accuracy I get on this, this is how I would solve it with coding. Like I can code in something right here to do it. And so this is like the more exact, like, does that make sense, Michaela? Like tables are okay. It's just an older way of doing it. Sorry, people who use tables. And that's why I'm against teaching it, because I'm like, we should do like the most modern ways. So generally speaking, I like to use the applets, which show you what it looks like. And then if I'm going to get exact answers, I'm going to use technology like this right here to say, you know, what is the what percent of areas below a z-score of 1.05, and I can just do p-norm right here, which is a function. And I think if I go to there we go. So if you want to talk about decimal place, yeah, thank you, Michaela. If you want to talk about decimal place accuracy, you can carry your decimals out to as far as you want, and you can enter in any z-score you want right here. What's even better is you can solve. Watch this. Let's go over to this question. Let's go over to a new question that actually has us use the applet. Okay, so we're going to solve this one using R. What's up, Andrew? Thank you so much. We got power for the moment. And look at this. We're going to solve these questions using R. So it wants the top 5%. And watch this. It wants the top 5% on a curve with a mean of 100 and a standard deviation of 14. So we need to go back to R. We're going to solve these last two ones using R just for the fun of it, because I do think it's fun. Q norm. And then you see it even tells us there's the percent. So if we want the top 5%, we need to go to the 95th percentile. That's where the top 5% is. And I think that's got it right there. Let me double check the answer, the question. 114, top 5%, round to 1 decimal. And then let's put this inside of here, a round and to 1 decimal. That rounds to that. Sure, why not? Oh, that was rounded to 1 decimal. So 123. 123. And the lowest 30%. Just change this right here. 92 points. You're crazy, R. 92.7. And the middle 70%. Middle 70%. So middle 70% is going to be the 15th and 85th percentile. So we got to run this twice. So the 15th and 85th percentile. Hey, what's up, Jonathan? Thanks so much. Is there a class that covers R? I'm considering getting it. Yeah, BAS 320. And if you ever want to see what the class looks like, just message me and I can send you some videos from it, so you can get an idea of what it looks like. Yeah, just let me know. I'll send you some videos from it, and you can get a look at what the class looks like. And for 114.5, 114.5. So we should get the answers right. Yes, look at that. So if you notice, I'm able to solve all these using R. I can put in the mean and the standard deviation. I can ask it to round it. I don't know why this one went haywire. Let me change my digits back, because that, you don't want your digits showing that many significant digits. So it didn't do that crazy thing right there. So I want 7 digits carried out on normal. That's setting the global options. So if you notice, R makes it pretty easy to solve those. I think we just got 2 more, and we've only got 18 minutes. What percent of adults are expected to have cholesterol levels over 210? Oh my gosh, we got to use the applets. Ah! Oh, let's do this one. Someone's gonna be wondering on this one. Let's do it, and then we gotta prepare for class. Let's do it. Big stretch. Here we go. Okay. Are we using the empirical rule or are we not? We're not using the empirical rule. What's up, Carolyn? Good to see you here. Okay, maybe this is the question Carolyn wants. She's like, yes, this question. I want to see how to do it. Let's explain this. So, yes, this one's confusing. Lucy, I'm glad we're doing this question here then, because I was going to call it quits. I was going to say, no more stats for today. That's it. We're done. Okay, let's take the question, put it over here on the side, and let's go ahead and put in our mean and our standard deviation to both sides of this. 183 and 30. We're putting the mean and the standard deviation to both sides of this, just so you can see. The mean and the standard deviation are now in all parts of this applet, and we can kind of get an idea of what we're looking at here. 68, 95, 9.7, all those are accurate. 183 is at the center, and the standard deviation is 30, so it needs to be this one. Just look at the standard deviations on the bottom to make sure you have the right one. What percent of adults do you expect to have cholesterol levels over 210? So we need to go above 210. What? Thank you so much, Clarissa, right there. Above 210, 18.41. And then what percent do you expect to have between these numbers? There we go. Blocking the numbers. Blocking the numbers. 8.6. Examine the interquartile range. The interquartile range is the middle 50% of the data. So it's going to go from the 25th to the 75th. We can graph this by going over to here. We've already entered in our numbers. We want 50% of the curve shaded, and we want to go between, and there's the middle 50%. So that is the middle 50%, and it wants to know the range of the IQR. So we have to take these two numbers and subtract them. Big number minus small number is how we find the IQR. Someone start yelling at me if I made an error. I don't think I did. Round to the nearest integer. Well, I did all that work just to find 40. The highest 15% is going to be the 85th percentile. It can also be graphed as the highest 15%. That's the 85th percentile. We could also ask for the highest 15%, just another way of doing it. And round to the nearest integer. That's going to be 214. We've done it. We've done it. Wait, I thought... Oh, that's the one we did. I hate that it doesn't show the question completed. Okay, last question here, which I think this is a little bit of a tough one. No, I know I've made mistakes on this one. Why? Which is a better summary of it? So we are definitely going to use the median because the data is insanely skewed to the left. What is a better summary of spread? Well, when you use the median, use the IQR. And because the data is insanely skewed to the left to the low, skewed to the low side. From a normal model, what percent of neighborhoods should have a percent white residents within 3 standard deviations? Okay, so 68, 95, 99.7. It says from a normal model, so assuming that's true. What percent of adult adults actually have a percent within 3 standard deviations? Okay, so what's the standard deviation? 20-ish. And then 82. So if you go from 80 up 3, if you go from 80 down 3 standard deviations, that'd be down to 20. And it looks like we're missing some. I'm between two answers. See, okay, here's the thing. I'm pretty sure the answer is going to be this one. Because they want us to say it's not appropriate. I was thinking it could be about 95. But this one... If you look from here to here, because I'm going down 3 standard deviations. Here's the standard deviation, 82. Yeah, so it's going to go down to about 22. It's going to go down to about right here, 3 standard deviations. So I'm guessing this is the right answer because they're going to say that it doesn't line up. Explain the problem using the normal for these datas. The data is skewed to the left, not to the right. The data has gaps and outliers. Got a little bit of gap there and outliers. The data is not symmetric. So that should do it. Really... Is it really that one? Oh my gosh. Wait, did I miss a question? Oh my. Now that's not fair. Now that's not fair. That's just not fair. Wait, my brain. Explain the problem. I told you I don't like this question. Within 3 standard deviations, that's correct. Median, skewed to the left. IQR, skewed to the left. 99.7. This one we know is correct because we checked it. Explain the problem. The data is skewed to the left. That's accurate. The data... Yeah, I know, right? Just email me. I'll fix it. The normal can't be used for this. That's a problem. It is unimodal. Is it really this? Really? I just might even delete this question later on. Oh, thank you so much, Alexander. Stretching. Oh my God, that's ridiculous. It says contains gaps and or outliers. Contains gaps and or. Well, I'm gonna go cry over this problem. It's ridiculous. It's ridiculous. I was thinking it was this. But that's got it, Alexander, for now. We're going to head off. I'll be teaching here in 12 minutes, right? 12 minutes. So I'll talk to everyone later. We got through all these problems. Email me about the project if you're working on it. I will talk to everyone later. Bye for now. I don't even know where my buttons are at. Oh, we got to play some... Wait, we'll do the quick outro. I don't even know. Wait. Here we go. Jason, we just need to film for another 4 or 5 hours. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.